So today we will be discussing the problem named most profitable path in a tree, and you are given an undirected tree with n nodes level from 0 to n minus 1, which is rooted at node 0, and you are given a 2D integer array named edges of length n minus 1. Obviously, if a tree having n number of nodes, then there will be exactly n minus 1 edges, and the edges of I denotes as ai and bi, indicating that ai is connected to bi and bi is connected to ai as well, basically bidirectionally. And at every node I there is a gate, and you are also given an array of even integers amount, where amount of I represents the price needed to open the gate at node I if the amount is negative, or the cash reward obtained on opening the gate at node I otherwise. So what it's trying to say is, if the amount of I is negative, that means you need to open that gate, and if the amount of I is non-negative, that means you got some cash reward opening that gate. And there is a game going on the tree itself, and initially a player named Alice is at node 0, the root node, and Bob is at some node located at Bob. They will basically give us an input where Bob is located at, and at every second Alice and Bob each move to an adjacent node, and Alice moves towards some leaf nodes while the Bob moves towards the node 0, which is the root node. And the next condition given is, for every node along their path, Alice and Bob either spend money to open the gate at that node or accept the reward. I have already mentioned about that section. If the amount is negative, that means you are paying some money to open that gate, or if the amount is positive, that means you are gaining some reward. Note that if the gate is already opened, no price will be required, and also you will not be gaining any cash reward. So if there is a player who have already opened that gate, then you will not be gaining any cash reward, neither you will be needing any price to open that gate, depending upon whether the amount of I is positive and negative. And also, if Alice and Bob reach the node simultaneously, basically at the same time, when they are trying to kind of go from one node to another, and if they reach at some node at the same time, they will share the price reward for opening the gate there. In other words, if the price to open the gate is C, then both Alice and Bob pay C by 2 each, and this is the reason why the amount I is given as positive, not positive, the even, so that we can evenly divide the amount to both of them. Similarly, if the reward at the gate is C, both of them receive C by 2. So if the amount of I is negative, then both of them need to pay amount of I divided by 2 in order to open that gate. And if the amount is positive, that means both of them will get amount of I divided by 2 cash reward. And if Alice reaches a leaf node, she stops moving. Similarly, if Bob reaches to node 0, which is the root node, he stops moving. One thing to notice over here, they have mentioned a note that these events are independent of each other, and you are asked to return the maximum net amount Alice can have if she travels toward the optimal leaf node. Okay, looking let's see the first sample case, where they have given us a tree with node 0 being connected to 1, and node 1 being connected to 2 as well as 3, and node 3 being connected to 4. And they are saying that Bob is standing at node number 3. So initially Bob is here, Bob is located at this point, and Alice will always be locating at this position, which is the root node. And similarly, the amount for each node is given over here. So the amount for node 0 is given as -2, for 1 it's given 4, and so on and so forth. And for this sample case, what would be the optimal way of going from root node to leaf node for Alice would be to let's see, we go to root number -2, and then he can go to this node. The moment he tries to go to this node, he sees that Bob is also going to this node at the same time, right? So they both will gain 4/2 as the cash reward. Plus now Alice has two options: either he will go to this node or he will go to this node, but the optimal way for Alice would be to go to this node. And since this node was already been visited by Bob, he did not need to pay any price over there, so he can directly go to the next node, which is the node number 4. And if we look at this closely, we can see that this node was never visited by Bob, so he will gain the price. Basically, the Alice will gain this price as 6, and if we sum them up, we get as 6, and which is the maximum possible answer over here for the Alice. What did we see over here? One thing to notice over here is for the Bob, the path is always constant, right? Bob will always try to move to the root node. So there is exactly one path for the Bob. He will basically go on to the first parent, and then second parent, and then third parent, and so on and so forth, until and unless he reaches to the root node. But in case of Alice, it does make sense to which leaf node he wants to go to, because we want to maximize something, right? So we just need to find that path such that that path give them the maximum value. Okay, so since we know that the path for the Bob is constant, we can try to formulate some steps given that we know the path for the Bob. So for the Bob, what we can do is we can maintain two things over here. What we can do, we will keep on going to upwards, since Bob need to do so, and we will kind of try to compute what is the time that Bob reaches to that particular node. So what I mean to say is, look at this node. So initially Bob is at 3, so we say that time to reach node 3 is 0. And why am I computing this? We will see later on. So we say that time to reach this node is 0, and Bob moves forward, and I say that Bob will reach to this node at time equals to 1. I am considering that to traverse the one edge, it's taking 1 time. And similarly, when the Bob will go upwards to node 0, so we say that time to reach the node 0 is 2. And what is the benefit of computing this one? The benefit of computing this one is, then we can know whether or not Alice will gain some amount, or they will share the amount, or directly the Alice will get all the amount that is located at some particular node, right? So we see that time to reach the node 3 is 0, and time to reach node 0 is 2, and time to reach the node 1 is 1, and we can generate this starting from node 3, and we will kind of build a parent array and then keep on jumping one step forward, and then we can simply compute this time array. And how do we know that whether or not Bob will get all the amount incremented in his answer, or they will share the answer, basically share the amount? We can do it. Let's say we are at some particular node, and if the time to reach Bob to that particular node is greater than the time to reach by the Alice, that means Alice can reach to this node 0 in 0 time, right? But in case of Bob, we have computed that time to reach the node 0 is 2, so that is greater. That means Alice will be the one who will be reaching that node first. So whatever is mentioned, whatever the amount mentioned at that particular node, we have to we do not need to share anything. Instead, that all particular amount will be incremented into the answer for the Alice, right? And then again Alice has only one option to move to node number 1. So Alice goes to node number 1 and says and sees that Alice will be there to reach the node 1 at time equals to 1. And as you can see over here, time to reach node 1 for Bob is also 1. So hence we can say that we have to now share the amount, right? Because both of them have reached to some particular node at the same time. So we need to increment the amount by sharing between both of them. And from there we have two options: either I want to go to this node, or I want to go to this node, right? So we'll kind of do a BFS algorithm, something like this, and we will try to visit both of these paths, and out of both the path, whichever gives us the maximum answer, we will consider that one. So the idea over here is pretty simple. We will create a parent array, and then from that parent array we will start traversing from the Bob node, and we will somehow compute this time array. And again we know the condition that if time to reach that particular node for Alice is smaller than time to reach that particular node by Bob, then we can directly increment all the answer to the Alice. Or else if time to reach some particular node by Alice is equals to time to reach to that particular node by Bob are same, then we have to share the amount. Or there is one other case: what if Bob had never visited some node? In that particular case also we will increment all these amount value into Alice answer only. So over here this particular node was not visited by Bob, and hence we were incrementing +6 to the Alice answer, and hence we were able to get the maximum possible answer for this particular case. I hope the idea is pretty simple. We compute the parent array from the node 3, we go upwards, compute this time array, and then again from node 0 we will do a BFS algorithm, start going downwards, start going to some leaf nodes, and then also maintain what is the maximum answer that Bob can have. And then out of all these computed leaf node, we will get the one having maximum answer. So for node 2, the answer that Alice would have gained is -2 plus 4 divided by 2, since both of them were reaching this node at the same time, plus what if the Alice decided to visit this node, then he would have incremented +2 in his answer, and the answer would have been just the 2, right? But if Alice had decided to go this way, the answer would have been -2 plus 4 divided by 2 plus 0 plus 6, and hence we get the answer as 6. So the total number of leaf node we have is 2 and 4, and we see the answer for the leaf node 2 was 2, and the answer for the leaf node 6 was 4 was 6. The answer for the leaf node 4 was 6, and we will output this result, which is 6. I hope this is clear now. So in code, what we can do is, first we will try to fill the parent array, and I have this function named fill parent, which takes input as a u some particular node parent and the parent array, and the fills the parent array. Basically, what is the parent of which node is the parent of which node, and so on. And inside over here, I declare this maximum variable to find just the number of nodes, and then we create the adjacency list, and out of all the edges that we have given, we create the adjacency list, and this maxi variable is just to keep track what is the number of nodes that we have. And then finally I am assigning that value to n, and then we create a parent array, and we know the parent of 0 is going to be -1, and then we call the function named fill parent, which is going to fill the parent array. And then I create a time array, and then I fill each and every one by -1. Why am I doing it? Why? Because initially what I am doing is, I say that for each and every node, the time to visit any particular node by Bob is -1, right? This is what I am doing, and then from that particular parent array, I will try to fill the time array. So time array will be replaced with 0, this will be replaced with 1, and this will be replaced with 2, and this one will be -1, indicating that Bob has never visited this node. And for this node also, the value is -1, mentioning that indicating that the Bob has never visited this particular node. I hope this is clear. And then we have this leaf array list storing the leaf nodes, although this is not necessary. And then we have a visited array and the resultant array, which will be storing what is the result starting from root node to each and every node, like what is the maximum answer Alice can gain starting from root node to any particular node, right? And then we do a BFS algorithm. We have a queue. We'll insert the 0 is the node number, and the current amount, and the current time he is at. So initially I am at root node, which is 0, and the amount at the root node is amount of 0, and currently at time 0, and we mark visited as 1, and the resultant of 0 is amount of 0. Maximum amount then that Alice can gain being at 0 is the amount at 0, right? And then currently we have the current node, current cost, and the current time. We pop out the current state, and then we go to all the childrens of the current node, and we check that if that node had already been visited by Alice or not. If it is not visited, we mark it as visited, and we check that if the current time plus 1 equals to time of v. By the way, this plus 1 is basically, since I have taken it 0 based, so I am doing it plus 1. And then if current time plus 1 equals to time of v, that means the current time plus 1, the time to visit by the Alice to this node v, is equals to the time taken by the Bob to visit this node v. If they are equal, that means resultant of that particular node will be the previous maximum answer, the current node u. Let's say we have this u, and we have already calculated the resultant for this u, and we want to go to some v, and we want to compute the resultant for this v. We want to add this to our answer, right? So that is what I am doing over here, the resultant of current node, and then plus amount of v divided by 2. Why? Because they both were reaching a node v at the same time. The other case is, what if the current time is lesser than time of v? This means that Alice was able to visit some node before Bob, or the time to reach that particular node is -1, meaning Bob has never visited that particular node. Then we have to increment entire amount to the Alice amount. So resultant of V equals to the previous amount plus the current amount. The entire amount will be added to the Alice answer. In other cases, we incremented 0, right? Alice will not be getting any answer. This means that Bob had already either visited that node before Alice. So we just will have to increment whatever was the previous amount. So resultant of current node, which is basically U over here. And then in Q we add the current state of V, which is the node V, and the answer for node V, and we will also pass incrementing the time, current time plus 1. And then whenever our resultant array is computed, we go to each and every leaf node starting from 1 to all the way till n, and if it is a leaf node, then we compute the maximum answer out of all the leaf nodes. Resultant of I stores what is the maximum answer Alice can have starting from node 0 to some particular leaf node, and then at the end of the day we output the maximum answer. And this would have been the explanation for the problem named most profitable path in a tree. And this solution does passes given that we have n as at most 10 to the power 5 and as is n minus 1.